Okay, that is NatureHacker's fourth law. Okay, now the fourth law requires a force transfer. You have to have a force on this body transferring to another body. So there has to be something else pushing this. This has to be pushed by something else to push the body, okay? That means there's three systems in this understanding here, right? Now, the fifth law takes this a step farther and says that a force is the second a force is applied to a body. The second a force is applied to a body, that body and the body that applied the force are now moving relative to each other in opposite directions than they were before. Here this one's moving towards that one, right? But then here, this one slows down a bit and that one speeds up a bit. Instantly they lose contact, and force can only be applied when they are in contact. So in a perfect situation, there would be no force able to be transferred between two bodies, because the instant this one touches it, the other one, they lose contact. Okay, that's the thing. The instant one body touches another body, they lose contact. So there can be no force transfer because the time is zero. The time of the force being applied is zero. Now we know this isn't the case. We can obviously apply forces to things non-zero, right? And they're contacting each other for non-zero time. But that means that there's another undiscovered law of Newtonian or mechanistic physics. So the question is, what is that law? And that law is that there has to be an infinite, in order to get a non-zero time in your force transfer, you have to be, that force has to be applied, that there has to be an infinite series of force transfers happening. Okay? There has to be an infinite series of force transfers happening. Now, what does that mean? That means that if I try to throw a medicine ball, what has to happen is there has to be force transfer. Let's use actually an easier analogy to start with. If you're pushing a boulder, can you just hold your arm out and just push the boulder? No, you can't just hold your arm out and push the boulder. You have to get behind it and you have to push it. Okay, now what's happening? Your hand is pushing it, right? Now that force is being transferred to your shoulder, to your back, to your foot, right? To the earth. That force is being transferred all the way along there. It's not just my hand applying a force to the boulder. It's the force being transferred from my hand all through my body to the earth and beyond is what really it comes down to. Is it has to be to beyond the earth. Infinitely. So that means that in order to create a non-zero force, you have to transfer that force in an infinite series of force transfers. Now that's all well and good, and you might just say, oh, well, you know, that's just an interesting philosophical idea, right? But we can actually apply it with mathematics and with mechanics. And how we do that is we say that the amount of time that we're able to apply a force to something, let's say I'm pushing a billiard ball, right? And I go and I'm applying this force. You know, my mass times my acceleration is this force, right? And it's hitting the billiard ball. So if it touches, you know, I have, let's say, a 500 Newton force, and it touches the billiard ball for 0.1 seconds before the billiard ball just jumps off in the other direction, right? So that would mean that with a 500 Newton force, we had a force transfer of 0.1 seconds, all right? Now, what that means is that and I'm going to define a constant called repulsion. So the repulsion is the 0.1 seconds divided by the 500 Newton force. So the bigger that time is, the bigger the repulsion is. Now, let's say I'm pushing a big waterbed, right? And I apply a 500 Newton force to the waterbed, right? And that force can apply for 2 seconds before it loses contact. Now, you would think that it doesn't matter how much time the force is applied for. But it obviously does, because power is force times time. So if you're applying that 500 Newton force and you can only apply it for 0.1 seconds to a billiard ball, but you can apply it for 2 seconds to a water mattress before they split ways, then more force will be able to be transferred. So the more kind of give the material has, the more force you could transfer to it, because you can contact it for a longer time. So yeah, you're basically giving space time to catch up with you. You're giving the universe time to catch up with you. You know, this is why, you know, if you're on a chair, right, like an office chair, and you swing your arms to one side and your legs to the other side, and then swing them back really quick, right? You return to the same spot. You know, you swing yourself and then you come back. But if you swing yourself and then come back really, really, really slowly, you can actually turn yourself. If you keep doing that, swing fast and then turn back slowly, you will turn yourself, and you can actually turn yourself, which is defying the first 3 laws of Newtonian physics. But this is the principle why. It's a principle of giving the universe time to catch up with you. And that is in the repulsion equation for the 5th law of motion. Okay, so the 4th law is interaction. The 5th law is repulsion. So we have the first law is mass. The second law is, I'll say, acceleration. The 3rd law is force. The 4th law is interaction. And the 5th law is repulsion. So it goes inertia, acceleration, force, and then we've got force transfer, and then we got force transfer series. So that's the progression that we have now. So now what we've done here is we've taken non-Newtonian physics and we have defined it to fit into Newtonian physics. We now have the laws of motion to define non-Newtonian physics. And we don't have it completely yet. I think there's still one more law missing, and that law will be the most important law of all, because it will have a constant. It will have a number constant, and we can think of that number as defining God, or defining the ether, or defining the universe, whatever. It's a universal constant, and it will be a number. I don't know what that number will be. So, yes, it's an exciting time. You know, now is the time, to start writing more equations for the 4th law and the 5th law. I have equations listed, just these basic equations, but they'll have to be equations for all sorts of things. Taking into account friction, taking into account viscosity, taking into account density, taking into account atmospheric pressure, taking into blah, 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 blah. We need equations now based on the 4th and 5th law to take into account all sorts of material properties. So, I don't know what the next law will be, but maybe you'll be the one to find it. I am the Nature Hacker. Do work.